Example 3. Write the equation of the line through the point -5 and 6 with a slope of -1/2. You have all the information you need, so substitute into the slope-intercept form. So remember that -5 is x1 and 6 is y1. The 1/2, which is the slope, will be m. So y becomes 6, m becomes -1/2, the x is -5, and we will be solving for b. So 6 equals 5 seconds, which was -1/2 times -5, plus b. This is where we are from the last slide. And when solving for b, you need to be sure to remember to use common denominators when adding or subtracting fractions. So 6 becomes 12/2. And 12/2 minus 5 seconds equals 7 seconds, or 7/2. And b equals 7/2. In this problem, I jumped and moved b to the other side right away. If you're not confident with that, keep b on the right side and subtract 5 seconds from both sides, and just switch your answer when you achieve it. So b equals 7/2. Let's plug those values that we solved for and put them into our formula. So we knew that m was -1/2, so we have -1/2 x plus, now we've solved for b, which is 7 seconds, and that is your answer. This is what example 5 looks like in your book, and it's a lot of information. What I want you to do is go ahead and rewrite this as an example as I'm going along and showing you. So we're going to look at the first part of example 5. They ask you to write the equation of a line through point P. So let's look at the graph. We have point P right here, and we need to find the slope first. So the slope is the slope of line K, which is going to be the rise over the run. Now, I chose to start at the origin, and that's my convenient point that I picked. So let's look at the rise. The rise from here would be 1, 2, and the run would be 1. Let me try that again to make sure that that still is on the line. 1, 2, and 1. So the rise over the run is 2/1, which is 2. So our slope is 2. We'll now find the coordinates of P and sub into our formula. If I take a look at point P, whenever we're finding coordinates, we use the x-axis first, then the y-axis. So I see that P is -3 to the left, and 1 down, which is -1. So our points are -3, -1. Using our formula, y equals mx plus b, I substitute the known values, and -3 is x1, -1 is y1, so y is -1. We just solved for m, which is 2. We substitute the x value of -3, and then we have our formula. We'll solve for b at this point, and we have -1 equals 2 times -3, which is -6 plus b. And if I subtract -6 from both sides, we end up with b equals 5. We can now enter the m and the b values into the formula. So y equals 2x plus 5. Now the second half of this example asks us to solve a perpendicular to line K. So to do this, we find the slope, but we multiply by the perpendicular of the slope. So our slope was 2. We solved that in the first part of the example. Now we're going to multiply by negative 1/2. It's negative reciprocal. And 2 times negative 1/2 would be negative 1. Substitute the slope of the perpendicular line, which is negative 1/2, and the coordinate of point P, which is negative 3, negative 1, into your intercept formula. Into your slope-intercept formula. So y is negative 1 equals negative 1/2. So in the first part you had your slope of 2. Now we've just substituted the negative 1/2 times the x-coordinate, which is negative 3, plus b. If we solve for b, first thing I'm going to do is set negative 1 to negative 2 over 2 so I can add or subtract. And we end up with b equals negative 5 seconds. And the last thing you do is enter m and b into the formula. And that will be y equals negative 1/2 x plus negative 5 seconds. Your homework for Lesson 3 5b is numbers 16 through 25. And here are some hints. For number 16, find the y-intercept first, then solve for slope, and enter the slope into the slope-intercept formula. Just a hint, in number 16 and 17, they both have the y-intercept at the origin. So your formula will look a little different because they have no slope on those two problems. Number 20, find the slope and y-intercept. Use the slope-intercept formula to solve for b. Be sure to rewrite the formula with m and b entered into the formula for your answer. And number 23, you are solving for a parallel line. After solving for m and b, graph the line and see if it is parallel to the original line. I'm available if you need help. Have a blessed day.